Hello everyone. I am going to deliver a lecture on fundamentals of programming in microprocessor. So the course content is the programming model of 8085, instruction set of 8085, then after programming of 8085. Before starting of programming of 8085, first we have to recall or review some basics of 8085. So here is a programming model of 8085. So in the above diagram, here is the accumulator, which is 8-bit, and flag register, which is also 8-bit, and here is a 6 general purpose register, which is B, C, D, E, H, L. These are used to store the data temporarily in microprocessor during the operation. Next is the stack pointer. It is a special purpose 16-bit register in microprocessor which holds the address of top of the stack. Stack is nothing but a set of memory location. Then the program counter. This register is used to sequence the execution of instruction. The function of program counter is to point the memory address from which the next byte is to be fetched. Both the stack pointer and program counter are 16-bit. Here the address bus is a 16-bit and the data bus is a 8-bit. So what is the role of register? The 6 general purpose registers, 8-bit register B, C, D, E, H, L, which I told, it is used to store the data. Only 8-bit, which is used to store the data temporarily during the operation. And they can also be combined as a register pair to perform 16-bit operation, which is BC, DE, and HL. And the accumulator, it is a special register which is a part of ALU, or we can say it is directly connected to the arithmetical and logical operation. Maximum operation are performed by the accumulator. So now let's start the instruction set of 8085. The instruction set is a binary pattern designed inside a microprocessor to perform the specific function. The entire group of instruction set of microprocessor supports is called instruction set. And these 8-bit binary values called the opcode or instruction byte. So we can divide the instruction set in different sections like data transfer instruction, arithmetical instruction, logical instruction, branching instruction, control instructions. With the help of these instructions, we can create a program according to our requirement. So first, a data transfer instruction. Data transfer instruction, that means we can transfer the data from outside the world to the microprocessor or from the microprocessor to the outside world with the help of registers and some special instructions. So we have examples like there is a first instruction mov move. MOV move RD comma RS. Here RD is the destination register and RS is a source register. Remember one thing, the RD and RS may be the register A, B, C, D, E, H, L. Like we have example move B comma C. What is the meaning of move B comma C? That means the content of C is copied to B. The content of C, whatever the content have in C, it is directly copied to B. We can take an example for this. So like mov move b comma c, it is a instruction. Let's suppose before executing this instruction the register b have 80h because it is 8 bit and c have a 43h. So after executing of this instruction move b comma c, the content of c is copied to b. So after execution this instruction, b is equal to c is equal to 43h. We can take another example. Mov move a comma b. So before executing this instruction the value of b is equal to 43. So after executing move a comma b, the content of b is copied to a. So after executing move a comma b, a is equal to b is equal to 43. So it is a first instruction. Move a comma b or move b comma c. Here another instruction move b comma m. M is one of the operand is memory location. Its location is specified by the content of the HL register. So the H is a 8 bit and L is also 8 bit and it combines create a specific 16 bit address and that address is called the memory. So in that memory whatever the content have in HL memory location which is transferred to B, or we can say we take example move a comma m. So whatever the content have m is copied to a. We can explain again like let's suppose in HL H have a 20 and L have a 50 and in this both combined and in this location the it have a 50h in that location. So if we write m o v move a comma m. So after executing this instruction the memory which I told earlier, the memory denoted by the HL pair location. So in H is 20 and L is 50. So both are combined 2050 it is the address and in that address the content of in that address is 50h. So the 50h is copied to A. So after executing this instruction A is equal to 50h. It is example. Let's suppose that we can take another example. Let's suppose H L have a different location like if it is 2040 and in that location the content is 54h and we have write mov move a comma m. So after executing this instruction the content of memory is copied to A. So after executing this instruction A have 54 H. So it is an example of a memory addressing. The next instruction is MVI. The full form of MVI: MV stand for move, I stand for immediate. MVI: RD comma data. RD is a destination register comma data. Data means any 8-bit data which is directly copied to the destination register. The destination register may be accumulator A, B, C, D, E, H, L or M. Anything like we have example MVIB 57H. After executing this instruction MVIB 57H, so immediately the 57H is copied to B. That means P is equal to 57H immediately. Next instruction LDA 16-bit address. The full form of LDA is LDA means load the data in accumulator from a given 16-bit address. So the content of a memory location is specified by 16-bit address in the operand are copied to the accumulator. Like we have an example LDA 2034. So we can explain in a notepad, like any example. We can take any example like this example. If we have any memory location, like we have a 2050, in that memory location we store the data 50H. If we write LDA 2050H, so after executing this instruction, the meaning of LDA: load the data accumulator, load the data in accumulator from given memory address. So after executing this instruction, the content in given memory location is copied to accumulator. So A bit is equal to 50H. LDA. It is an example. Here one more instruction is like LDA. It can read the data or load the data from outside word or given memory location to the microprocessor. If we want to write the data from the microprocessor into the memory location, so we can use another instruction STA, comma 16-bit address. Like if we have A is equal to 50H, so if we write example STA 2030H, before executing this instruction, let's suppose in 2030H have a data 25H, let's suppose. So after executing STA 2030H, the content of accumulator is copied to or write to in a given memory location. So what is the content, content in accumulator? A is equal to 50h. So after executing this instruction, 2030 will change to 50h. So it is the example of STA